All right, so here's example one. Boom, booyah. All right, so we have example one, and we're going to graph out our actual function, and then we need to find its inverse. So we need to actually graph out the original function and graph out its inverse. So we're not actually trying to find the actual equation of the inverse. We're just trying to graph it out. That's easy. Simple, not hard, Mr. Hall. We got this. We got this. We ready. We ready. We ready. We ready. All right. So we're going to go ahead and do our equation here. We're going to make a table. And with this table, we're going to go ahead and work things out and set things up so that it's not something that's hard, but that is actually like this very simple, very easy to do. And I want to make sure that I have everything up here so I have enough room. And now with these, I'm not going to spend time actually like solving it out because you guys already know how to solve this stuff out. So the numbers that we're going to use for x though are going to be the same numbers every time. So -3, -2, -1, 0, 1, 2, 3. That gives us a great idea of what's happening on both sides of the center of the origin, 0, 0. But then it also like gives us like what's going on outside. This is going away from 0, 0 and everything. So remember we were talking about our continuity and talking about as x approaches this or x approaches that. Yeah, that type of stuff. Right. So if you substitute -3, -2, -1, 0, 1, 2, 3 into this, you will get these answers: 1.5, 2, 2.5, 3, 2.5, 2, and 1.5. So if you want to go back at some point, go back and watch and look at that and actually find out what those values are by putting it in yourself, go for it. It's good. All right, now for my second table here, though, I'm going to go ahead and actually do the inverse. And if you remember back from what we just wrote down of how to find the inverse, we said when it comes to graphing, all we're going to do, we switch x and y. And this is talking about graphing. So with this, we're going to focus on that part when we're making our table here. So we're not going to make this hard or difficult. We're going to make this simple and easy because we did the hard work was actually this first table right here. All right. So we're still going to call this x and f of x. But remember we said we're going to switch x and y. So whatever your y's are here become your x's here. Whatever your y's are, your x's becomes your y's. So I'm going to write this as 1.5, 2, 2.5, 3, 2.5, 2, and 1.5. Because those are our y values that are now our x. We just flipped them. All right, and then our x values, original x values, become our y values. 1, 2, and 3. All right, so with that, that's how we find the actual function or how we find the values for the inverse function. And now all we do is graph both of these on the same graph. So we're using our ordered pairs and we're going to graph them on the same graph. Oh my gosh, this is going to be so easy. Oh my gosh. Oh my gosh. Oh my goodness. Oh my goodness. All right. So with this, we're going to go 3 in all directions. So we have that. Then this is our axis. Then we have okay, so I'm gonna go ahead and draw these out really quick. Get her done. But again, like I said, we're gonna go 3 in all directions. Hopefully it looks better on your side. Mine looks whole like jacked up a little bit, but it's okay. We are still gonna live, and it's still gonna work right. All right, so Mine looks a little bit jacked up, but it's gonna be okay. So this is what mine looks like. Oh my God. So we label everything. Oh, the Lord. Help me, Lord. Help me, Lord. Help me, Rhonda. Help me, Rhonda. All right, so for our first graph, we're going to go ahead and use use this table here for our graph. So we're going to do -3. So x equals -3. And we're going to go up 1.5. So that's 1 and then 0.5. Then we're going to do -2, go up 2. We're going to go -1 and 2.5. And then we go up 0 and 3. And then we do 1 and 2.5. We'll do 2 and 2. And then we'll do 3 and 1.5. And again, all we did was just graph what was on the table. So 3 and 1.5. So over 3, up 1.5. 2, 2. We went over 2, up 2. 1, 2.5. 1 over 1, up 2.5. And we did all those points in the table. And then we connect them. Okay, good, easy, not hard. We got this. All right, so that is our original function. So let's label that as f of x. All right, now when it comes to the second table, the inverse, we'll do 1.5 and -3. We'll do 2 and -2. We'll do 2.5, -1. We'll do 3 and 0. So it stays right there. We'll do 2.5 and 1. We'll do 2 and 2. Sorry, I lost my train of thought there real quick. And then we do 1.5 and 3. Now, before we actually graph it out, you can kind of see like what we were talking about when it comes to our if our original function, using our original function to tell if it's actually going to be an inverse. If we look at, before we actually graph this out, if we look at this part here and we do our vertical horizontal line test on the original function, if we go straight across, we hit 1 here and we hit 1 here. So that automatically means right here, this original function, the inverse function, the inverse is not a function at all. The inverse is not a function. And so let's go ahead and graph this out. So that is really cool. Like we just kind of, we can look at it now and see, okay, well, if I do a vertical line test right now, I can see that it hits in 2 spots. So therefore the inverse is not a function. But if you look at the original and just go from here, we can automatically say from there, it is not going to be a function. And our inverse is not a function. It's an equation, but it's not a function. So cool. So that is our inverse and our regular equation, our original equation. All right. So that's it, guys. That's all you have to do when it comes to these. Example 1, out.